Well, today I would like to introduce one problem on factorials. The question is very straight. How many zeros end with 100 factorial is the question to be answered. You know factorials, right? For example, what do you mean by 5 factorial? 5 into 4 into 3 into 2 into 1 is called a factorial 5 or 5 factorial. In both ways you can say. So the product of all these 5 digits and the output of these 5 digits, the product of 5 digits would represent the value of 5 factorial. So 5 into 4 into 3 into 2 into 1 equal to 120. Therefore 120 is the value of the 5 factorial. Similarly, what is 10 factorial? 10 into 9 into 8 into 7 into up to so on into 3 into 2 into 1. So the product of all these 10 digits would represent the value of 10 factorial. So do you know what is the value of 10 factorial? It may not be that much easy as you have calculated for 5 factorial. You need a little help from the calculator. So for your information, the 10 factorial value equal to 36,28,800. So if you go on increasing the factorials value, for example 20 factorial, 30, 40 factorial, so the output of that value will be exponentially increasing. Now the question is asking you about 100 factorial. Of course, the question is not asking you about the number that represents 100 factorial, but instead it is asking you about to find the number of zeros end with that 100 factorial number. So calculator will not help you, I am sure about it. The calculator will not display that largest number that represents 100 factorial. Even you cannot get some help from the computers also by writing some programming. Even that will not display the full number that represents 100 factorial. But luckily they are asking us to find about the number of zeros end with that number, that factorial, 100 factorial. For example, just now we talked about 5 factorial. So 5 factorial equal to 120. So if the question is asking you about to find the number of zeros that end with 5 factorial, you can say that 1 0. Similarly, we know that 10 factorial equal to 36,28,800. So if the question is asking you about how many zeros end with the 10 factorial means, you can simply say that 2 zeros end with the value of the 10 factorial. Similarly, we need to find how many zeros end with 100 factorial. Fine, here I would like to introduce one technique of problem solving. When there is a largest degree of complexity in the problem, let us try to reduce it and then let us look at whether it can be manageable to solve it. So 100 factorial is a very big, toughest task. So let us see, decreasing the complexity would make us a way to know about the approach in solving this problem. So reduce the complexity, reduce until you feel that that degree of complexity is comfortable for you to make an attempt to solve the problem. Because this strategy will help us to give at least a beginning idea, a beginning approach, a very positive approach to solve the problem, and later on we can go for the actual original problem with the highest degree of complexity. Now the given problem is 100 factorial to find the number of zeros end with 100 factorial. So it's very high level of high degree of complexity. So now let us look at 90 factorial. No, still it is very complex. 80, 60, 50, 40, yeah, still it is very complex. So 30, 20, 10, yeah, I think 10 factorial is little comfortable for us to start a beginning and to develop some logic towards the final answer. So just now we talked about 10 factorial. Its value is equal to 36,28,800. So we know that the number of zeros end with the 10 factorial is 2 zeros. We can say that. Now let us look at some basic concepts, fundamentals from mathematics, and let us develop some concept or an idea or a methodology to approach the problem at this range, and then we can look for other ranges to get the full solution for the initial problem, which is finding the number of zeros end with 100 factorial. Now the range 1 and 10 is represented by the 10 factorial. So the product of all these 10. Now we know that there are 2 zeros that end with the value of the 10 factorial. Now we also know that from the fundamentals, whenever 10 is multiplied by any number, that produces 1 0. And 5, the number 5, when it is multiplied by any even number, that will also produce 1 0. We know these two fundamental concepts. Now let us use these two to address the whole issue, the big problem at 100 factorial. Now let us look at the range from 1 to 10. So there is a 10 at the end of this range, so that 10 produces 1 0, and there is a 5 in the middle, 1 into 2 into 3 into 4 into 5 into 6 into, so there is a 5 in the middle. So that 5 when multiplied with any even number, that will also produce 1 0. Therefore the range between 1 and 10 will produce 2 zeros. Now let us look at the next range, 11 to 20. So this range will also produce 2 zeros, as there is a number 20, 10 into 2. So the factors for 20, 10 into 2, so that 10 would produce 1 0, and there is a number in the middle which is 15, the factors for 15 is 3 into 5. So that 5 when multiplied with a even number, that will also produce 1 0. Therefore the range between 11 and 20 will produce 2 zeros. Now let us look at 21 to 30, the third range. As you assume or as you think, this range also will not produce 2 zeros, instead it is little typical. For example, this range 21 to 30 is consisting of 30 at the end. So the factors for 30, 10 into 3, therefore the 10 produces 1 0. But we have a number 25 in the middle, which is 5 square, that is 5 into 5. Therefore these two 5s when multiplied with any two even numbers, that they will produce 2 more zeros. So the range between 21 and 30 will produce 3 zeros. So let us recall so far what we have done so far. So 1 to 10 range will produce 2 zeros, 11 to 20 will produce 2 more zeros, but 21 to 30 will produce 3 zeros. So now 31 to 40 will also produce 2 zeros, as in the case of first and second case, and 41 to 50 will produce 3 zeros, because we have a number 50, 10 into 5 is the factorization for 50. Therefore 10 and 5, these two 10 and 5s produces 2 zeros, and we have a number 45 in the middle, which is 9 into 5. So this 5 will also produce 1 0. So the range between 41 and 50 will produce 3 zeros. Now 51 to 60 will produce 2 zeros, and 61 to 70 will also produce 2 zeros, but 71 to 80 will produce 3 zeros. Why? Because we have a number 75 in the middle, which is 15 into 5. So the factors for 15 are once again 3 into 5. So there are two 5s, so these two 5s will produce 1 0, and 80, the factors for 80, 10 into 8, so that 10 will also produce 1 0. So the range between 71 and 80 will produce 3 zeros. Now 81 to 90 will produce 2 zeros, as in the previous cases, and 91 to 100 will produce 3 zeros now. Why? Because the factors for 100 equal to 10 into 10, so these two 10s will produce 1 0, and 95 has got one factor as 5, so that will also produce 1 0. So the range between 91 to 100 will produce 3 zeros. Now if you conclude the whole process what we did so far, so there are 6 ranges of numbers that produce 2 zeros, and there are 4 ranges that produce 3 zeros. Therefore 6 into 2, 12 zeros, and 4 into 3, 12, 12 plus 12 equal to 24 zeros. Therefore 100 factorial number, the value that represents 100 factorial, would end with 24 zeros. So this is how we can conclude. Now let me little extend the problem to make the concept very concrete. Just now we found the number of zeros end with 100 factorial. Now let me little extend further to have a little more complexity. So how many zeros end with 120 factorial is a question to be answered now. Now if you recall the whole process what we did so far for 100 factorial, that they end with 24 zeros. Now 101 to 110 will also produce 2 zeros as in the previous logic, and 111 to 120 will also produce 2 more zeros. Therefore up to 100 factorial 24 zeros, but 101 to 120 will produce 4 zeros. Therefore there are 28 zeros that end with 120 factorial. I would like to extend a little more. How many zeros end with 130 factorial? Can you calculate? Yeah, just now we did up to 120 factorial, so totally 28 zeros. Now 121 to 130, as you assume, that will not produce 3 zeros but 4 zeros, because of the reason there is a number 130 at the end of this range, 121 to 130. The factors for 130, 13 into 10, so that 10 will produce 1 0. But we have a number 125 in the middle, which is 5 cube, that is 5 into 5 into 5. Therefore, these three 5s, when multiplied with the three even numbers, they will also produce 3 zeros. Therefore, the range between 121 to 130 will produce 4 zeros. Therefore, the total number of zeros that end with the value 130 factorial is, so up to 120, 28 zeros. Now 121 to 130, 4 more zeros. Therefore, total number of zeros that end with 130 factorial equal to 32. So that's how we can find the solution very easily.